Hi everyone, welcome back to Be a Tech Pro, the podcast for everyone who wants to be a tech pro. And today we are talking about indexes in SQL. And we will be talking about what are indexes, the different types of indexes, how indexes work, and of course some best practices for using indexes. So cool, let's get going. So firstly, what are indexes? So indexes are database objects which improve the performance of your data retrieval operations. The data retrieval operations, okay? So it might actually slow down some of the other operations, but we'll cover that towards the end. So if you think about an index, it's kind of similar to an index in a book, which helps you to find information that you need. The index in SQL is very similar. It creates an index and it tells you that you're looking for this particular word on that page and that page and that page over there. So let's look at the different types of indexes. So number one, I'm going to talk about clustered indexes. This is one of the most popular indexes that you will probably use in SQL. You can only have one clustered index on the table. And the reason for that is because a clustered index physically sorts the data in your tables. Okay, so if you put a clustered index on the first name column, it's going to physically sort the data in your table by first name. If you put it on ID, it's going to physically sort the data by ID. So you can't physically sort it by multiple columns, therefore you can only have one clustered index on the table. So it's typically created on your primary key column because that's generally the column that you use to join. It doesn't have to be, but it is typically done like that. And of course we get clustered indexes, but we also get non-clustered indexes. Clustered indexes have a separate structure from the data rows. You can have multiple non-clustered indexes on the table. It's typically used for the columns used in your where clause. So if you think about when you're searching where ID equals 3, name equals Kevin, and last name equals Naidu, for example, those are the type of things that you're going to add into your non-clustered index. Generally, what you'll find is some people will create what's known as a covering index. And what a covering index is something that will cover all the columns which get used in your where statement, as well as the columns that actually get returned in your select as well. So generally when you're creating an index, you'll have your key columns. So if you think about your where statement, if it's where first name equals Kevin and last name equals Naidu, you would have first name and last name as the keys in your non-clustered index. And in your select row, you might have something else like date of birth being returned as well. And you can add that as an include column. So the include column won't be in the actual keys of the index itself, but the index will then know, okay, cool, I need to return the date of birth as well because that's required in the select statement. So an index that covers all the columns that you need for that particular query is what you call a covering index, and those are typically non-clustered indexes. Then you also get unique indexes. That's pretty straightforward. It's an index that ensures uniqueness of data in a particular column. These indexes can be clustered or non-clustered. A good example for a unique index would be on your ID column, for example. You don't want to have multiple IDs, and so you can ensure uniqueness on that. And then an index which isn't used that much is your full text index, and that's designed for querying textual data. And it actually supports complex queries like searching for words or phrases within text columns. You can also support various forms of inflection for a particular word, so it doesn't have to be the exact word. It can be something very similar to that. And full text indexes are extremely fast when searching for very specific words in big strings. One of the reasons why I don't use full text indexes is because, unlike a normal index, if I was to create a non-clustered index now, it would first create the non-clustered index and then it will take some time to build it. Once it's built, you can start using it. A full text index, on the other hand, is a little different. The index becomes available as soon as it actually starts adding data into it. If you have a table that has 1 billion rows, if it has indexed 10,000 rows, that index now becomes available. And if you query that index, it only brings back the results for those 10,000 rows that's been indexed. Maybe you search a minute later and it returns 13,000 results because it keeps indexing. So for that particular reason, I have never used it that much. It also uses up a lot of space and resources, so you find in most companies to switch it off. If you do need to search through text, it is a good option, but just be aware of the issues that you could possibly have. At least those are the issues which I've had, and so I just stayed away from it for those reasons. You also get what you call filtered indexes, and that's basically just includes a subset of rows in a particular table. That's useful for columns with a limited number of unique values. So all the indexes we are speaking about are generally what you call your B-tree indexes. These are your row level indexes. But you also get other ones which are your column store indexes. And these actually, instead of indexing by a particular row, do index by a column. And the first one is a clustered column store index. This stores data in a columnar format. Columnar, am I saying it right? Columnar. I don't really know how to say that word actually. Anyway, it stores data by column, okay? And the data is actually highly compressed. And the reason why it can be highly compressed is because if you think about the column name, there might be similar names in that name column. There might be a Kevin and a Gary and a Shane and a David and a Anna and a Inga. And because you can now see out of these million rows, we actually have 1,000 unique names. So instead of having a full index with all the million rows in it, you can have a very compressed index with just 1,000, and Inga can be found on that row, that row, that row, and Kevin can be found on that row, that row, that row. And so because of that, you can get a lot of compression when using columns to indexes. Clustered columns to index is very good for data warehousing and analytical workloads. And I use data warehousing specifically there because clustered columns to indexes are terrible in a live environment. I have an example of when I was using a columns to index on a live table in an OLTP system. And this table was being updated every second basically. It had a lot of writes happening in it. And because of that, this columns to index was being updated constantly. And because it was being updated constantly, the reading from the columns to index was terrible. And so the performance of the reads actually slowed down significantly. And as a result, it caused out the locks. And then that also led to the inserts being slowed down as well. And so it became a very terrible situation where everyone's saying, what's wrong? What changed? And I was like, I wonder if it's a columns to index. I don't think it can be. But then I took it off, and as soon as I took it off, all the locks were gone and performance improved. Be very careful with clustered columns to indexes. It's fantastic in a warehouse system that changes less frequently than a live system. But in a live system, which is being updated on a regular basis, be very, very careful. Also, you can only have one clustered columns to index per table, just like the other clustered indexes as well. So keep that in mind. Now, of course, if you do want to use a columns to index on a live system that gets updated frequently, you can use a non-clustered columns to index. So remember the non-clustered indexes we spoke about previously. It's basically just pointers to the actual data. Same thing with this. Non-clustered columns to indexes does not actually store the data. So it actually points you to where the data can be found. And this can be used in combination with traditional row store indexes, which we spoke about previously. I have a table that I've worked on that had about 8 billion rows in it. Yes, 8 billion rows. And searching through that was such a breeze. It took me a few seconds to find a name because the clustered columns to indexes are so powerful. But even the non-clustered columns to indexes combined with B3 indexes are fantastic. Now, when you're using indexes, if you look in your execution plans, you'll start seeing things like an index scan and an index seek. And index scan basically means it retrieves all the rows from the table. And index seek means it's going to retrieve selective rows from the table. Generally, you want to see an index seek. That means that it's going to be looking at less rows. If, however, it's going to be looking at more rows or the table's very small, sometimes SQL Server does actually ignore the index. So you might find some index scans on tables which have indexes, and that's just because SQL decides it's faster just to go directly to the table instead of using an index. Don't get alarmed when you have an index on the table and it's not being used. It's just because the volume might be very, very small. And as I mentioned, you can use your execution plan to look at which indexes are being used. You can also look at your query optimizer. There are a couple of tools that you can use to actually find that out. You can actually force SQL to use a certain index as well. So you can actually type in the index name in your query and make sure that SQL uses that index. The problem with that though, and I advise you never ever do this, is if you do tell it must use this index, if someone drops that index, your query breaks. So just don't do it. I shouldn't even have mentioned it, but just don't do it. And indexes require maintenance because fragmentation does happen when the index is created initially. It's sorted according to your parameters, but as data is added and deleted and updated, things do change. And so fragmentation does happen. So regular maintenance tasks are required in order to rebuild and reorganize the index. This will slow down the system when it is happening. So just keep that in mind, because if you have too many indexes on a table, this will slow down your performance dramatically. And that brings us to some of the best practices for indexes. So number one, select the right columns. Frequently search columns in your join statement, columns in your where statement, in your order by clause as well. Those are the ones that you want to add into your index. If it's something in your select statement, rather include those in the include section of the index. Don't put it into the keys, but anything that's searched by in the where statement, in the order by, or in the join statement, please put those into an index. And of course, monitor performance. So SQL Server has some built-in tools like the Database Engine Tuning Advisor and a couple other tools which you can get, which are third-party tools from Redgate and a couple other places where you can actually use to monitor the performance of your queries and the indexes as well. And of course, avoid over-indexing. So what I mentioned earlier on is when the index fragmentation happens, you have to rebuild and reorganize the indexes. If you have multiple indexes in a table, when it has to rebuild and re-index, it has to rebuild and re-index all those indexes which are happening, which exist on your table. If you have 10, it will be 10 that gets rebuilt. If you have 50, it's going to be 50 that's going to be rebuilt. And that all has a performance hit on your system. So keep it down. And remember, it will also slow down your insert and update statement as well as your deletes. Because every time you do an insert, update, and delete, it has to update that index, which then slows down the system. Okay, so if you have 3 indexes all touching on the first name column and you update the first name, those are 3 indexes which all have to be updated. And the best way to learn about these things is just to experiment. Indexing and performance tuning in SQL is an art, it's not really a science. So you might have to put 2 indexes on a table to improve performance. Maybe you only need 1, maybe you need a covering index, maybe you need 3 indexes. It all depends on how you are querying the data, and there's no right way or wrong way to do it, but just see what is the optimal solution for your particular work. And as you are learning some more, you'll start figuring out some nuances. For example, when you are doing an index rebuild or reorganize, you'll see that the performance of your system slows down, and that's because the indexes become unavailable. So how do you get around something like that? Well, you can maybe upgrade your system to SQL Server Enterprise Edition because they have online indexes. So while the index rebuild and reorganize is happening, the indexes are still available, and it will then rebuild a set somewhere else. And once that rebuild is done, it will then swap it out basically, and then you have your updated index. So those are some of the benefits you get from an Enterprise Edition. But as you're learning more about this topic, you will start touching on different parts of SQL, which can then help you become an expert on things like this. And of course, if you want some more information, you want to go to beatechpro.com to get out some more resources. I also have a sheet which will cover a couple of the indexes which we spoke about in this episode. I'll leave the link in the description. And that is it from me. Remember to follow me on the socials as well, mainly on the X and the website. Everything will be in the description. I'll catch you in the next one. Stay data driven. See ya.